All right. All right, that looks like it's working. All right. How does this shit work? I need to figure this out. Sorry, people, if you're watching. Give me one moment. I don't even know if I'm supposed to be showing this. Should this be on like a separate screen? I'm so confused right now. I just want to make some snake. Guard your privacy, abide community guidelines. Okay, so what I'm gonna do is I'm gonna create a new iOS app, but I do want to like put this somewhere else so I can go view it in a couple of minutes. Whoa. Let me see. Okay, so I've got no viewers right now, and I'm just going to keep this right here. And I'm going to move this up so that I can see who the hell, if anyone's watching, so I know if I'm talking to myself. All right, so I'm going to make some snake with metal shading language. And if you can't hear me, just let me know. There's not really going to be a way for me to tell, but I'm new. All right. What is this? Okay, cool. So, yeah, let's make some snake. I want to make snake using metal shading language. If you guys have ever used metal shading language, it's pretty awesome software, or I guess SDK. So what I'm going to do is I'm going to create a Cocoa app. I'm going to go to next. Let's go snake. And I've already made snake on this computer, so I'm going to call it snake 3.0 because I think 2.0 is already taken as well. But, yep, this will be under tutorials. We're going to go next. I've never actually done this live, so let me know how it's going. So I'm going to go project, sure. I'm going to create Snake 3.0, and bada boom, we have Snake 3.0. The next thing I'm going to do is I'm just going to get my iTerm up and running real quick. Because I'm going to want to do some Git stuff. So I'm going to go cd documents, what is it, projects, and snake 3.0. So as I'm doing this, oh, okay, git status. So as I'm doing this, I'm going to be pushing up to a branch. So if you want to pull down any of the changes, feel free. We can work through this together. Let's see, on branch, nothing to commit. All right, so let's just push it. And no, I'm not even going to do that. I'm just going to do the baby way. I'm just going to go into GitHub desktop because that's the easy thing to do. So I've already made snake. Snake's over here. I don't know if you can see it. I should probably bring it over. I think over here just in case. So this is my original snake. This is the snake that I made without doing. Okay, all right. It's probably because I deleted everything. Give me one moment. So if I go into my res folder and look through here, they're all there. What's your deal? Clean build folder, then run. Okay, that looks like it might be working. Sip on some wine. Oh yeah, everything's missing. All right, so what I need to do is I just need to go get my apples again. My apples are on my desktop. Dude, this is worth the wait. You're gonna love this. All right, apple 0 through apple 4. I'm gonna delete them real quick right here. And then I'm going to drag them on over. I haven't actually started yet. I'm just showing you my current apple, my current snake that I have going right now. So you know what we're going to be attaining to get to. Hopefully tonight we'll get a lot done. I'll fly through this stuff once. Kind of get the hang of the whole streaming concept. I wore my white shirt, so yeah, I don't know how to say that. Check it out. All right, so this is Snake. I don't know how it looks on your guys' screen, But this is our snake game, and as you can see, we can kind of just pick up apples. And I added some lighting. This snake looks like a... it looks inappropriate, but that's okay. I don't want to swear or anything or make any like crazy jokes on here. But yeah, so he moves around as fast as you want. He goes through the walls, and also he dies. So as you can see, his eyes are like X'd out, and he ate his side, and the sides is red. So this is what we're going to try to work for. I'm probably going to swoop on a lot of the code that I've already written. I'm just going to go and copy paste it, and then we'll talk about it. But yeah, whatever. Let's get at it. So this is my snake. I'm going to throw that on desktop 2, go back to desktop 1, because all I need to do is go to GitHub desktop, add a local repository, go here. Let's go add projects, snake 3.0, open, add repo, and yeah, that's that. I'm going to publish it. Publish snake. That's a good description, I think. I'm not going to keep it private. Actually, I'm going to keep it private. And if you want the code, let me know. Actually, yeah. So I'm going to keep it private because only people who watch this get the secret code. If you want the code, let me know. Oh, hey, what's up, Peter? Peter. Thanks, bro. Let's make it. I don't know if you can actually hear me. Yeah, Peter Gilmore. Okay, so now Snake should be live. If you want it, let's just go to GitHub real quick. I'm just getting set up. I haven't actually set up anything yet. I wanted to do all this on stream. My girlfriend's babysitting. She might come home anytime, but figured I'd just stream while she's away. Let's see here. So I want to go to my new Snake 3.0. So let's go to my repositories. How's this thing work? If I'm gonna actually put it in the description. If you want the code, message me in the chat place. I don't know what it's called. You know what? I'm just gonna paste the link. Yeah, if you want it, let me know. Cool. How the fuck do I share this? I'm gonna try to keep my swearing down as much as possible. Let's see here. Set up templates. I'm just gonna make it public. You know what? We're making it public. Snake 3.0. Confirm. I might need to do some two-factor. Nope, apparently not. Cool. Snake 3.0. And then I'm going to take this, and I'm just going to throw it inside of our... throw it inside here, inside of the description. So now if you guys want to follow along the code, I'm going to be pushing it up, and you can be pulling it down if you want to clone it locally. Actually, let's go here. You can clone it, do whatever you want, but I'll be pushing up if you want to be pulling down. Catch my drift. All right, I haven't actually done any code yet. All right, so if you see my tutorial series, which all 900 of you who are viewing this probably haven't, I'm going to set it up exactly the same way. So I'm going to create a new folder here, new group. I'm going to call it other files. That's what I like to call it. I'm going to use a lot of the same concepts from my tutorial series to make this. I want to make sure my RAM isn't too... got like way too many things running right now. I don't need iTerm. Just another thing I don't need. Rolling. I'm going to close that so that this runs optimum speed. Okay, I'm going to do other files. Create a group. I'm going to go up to the main settings file. I'm going to go to build settings. I'm going to go to search. I'm going to go to entitlements because I've moved my entitlements into the other files and I've spelled this wrong. And we need to change this right here to other files. Yo, since you've done this before, how about trying to do... Oh, shit. I could! No, I could. That's actually a good idea. The bridging header would be a good idea. Yeah, I've never actually done that before. I've never actually created the bridging header and then created the structs to be shared. I mean, I can give it a shot. All right. I'll tell you what, Peter. I'm going to do it. I'm going to do it just for you. So, yeah, let's do it. The next group I'm going to make another group outside. I'm going to call it, let's just call it display. This will contain all of our display logic. I'm going to throw my main storyboard in there. Oh, I forgot about my general. I'm just getting the main setup, so you don't actually need to be coding that alongside with me if you are. I'm going to get all the setup ready, and then you can pull it down if you want. So there we go, other files, main storyboard. I'm going to need to create a new file. And this new file is going to be a Cocoa class. You can just create a Swift class if you want. It's going to be an MTK view, and I'm just going to call it my game view. And Swift, put it right there, and bada boom. This will need to be metal. I don't know why it does that. I don't want any of this. Game view, we need an init. So init, that'll be with this coder, super.init. Coder. My computer's being really slow right now. Just done this so many times. All right, game view, and the next thing I need to do is I need to go and delete my view controller. Done, deleted, gone from existence. And let's go into my main storyboard and delete a couple more views. I'm doing it as a square because I don't really feel like dealing with aspect ratios with Snake. And then I'm going to go into the view controller. I'm going to remove this view controller class on top of there, and then I'm going to go up here, click on the window. Let's just change the name of the window to be Snake 3.0. There's not even like a 2.0 really. I never created a 2.0. It's just I didn't want to delete the file on my computer. That's ridiculous, deleting files. Cool. Now it's Snake 3.0. If I run this, actually, you know what? Stop it. Let's go to game view. Oops. When I meant game view, I meant let's click inside this giant thing right here and make this the game view. And press enter. Run it. Check YouTube. See if anyone's saying shit. All right. Okay. Yep, Peter said something. You're like the only one in here watching, so I'll do whatever you want, man. If you want to help me through this, if you've ever done it before, you let me know. I know it automatically creates a bridging header, but yeah, we'll see. That runs. All right. So to start it all off, I'm gonna put all the logic inside of this main file, but you know we can extrapolate all of that into different files as we go. But let's just kind of get like a hello triangle going, and then we'll move on from there. So the next thing that we want to do is we need to make this thing draw. So we extend the MTK view, which means that we have accessible to us the draw function. So I'm going to go extension game view down here as an MTK view delegate. We need to delegate the draw function, the draw calls down here. So draw. I'm going to do the in view with the rect. And then above draw, we need to also do, just start typing MTK view. Oop, I forgot I need to push this up, huh? Self.delegate equals self. Yep, let's push this up. So I'm going to go here. I'm going to go initial commit to master. If I don't respond, I'm going to try to check this every so often. I'm going to push it up. Should be going up there. And inside of the description, you should see we have this. Please check the video. Ooh. Hey, Peter, is the resolution decent? This is saying that the resolution isn't that good. There's got to be a way to change that. Huh. If you can't see it, you gotta let me know. I want to make sure that this looks somewhat good. It looks like... Okay, cool. Cool beans. Thank you. Snake 3.0. Yep, okay. And I pushed it up, so all these changes so far should be up in the repository. Initial commit. So if you did want this code, it's up there. All right, I'll stop talking about it and start doing it. All right, the first thing we need to do is we need to get our render pipeline state. No, let's start with creating. Let's clear the screen. Yeah, that sounds like a good place. So first thing we'll need to do is down here in the draw function, we can go let. Probably make this bigger. Let what am I doing? So let's just go. I have the device. Yeah, so I can go let command buffer equal. We need a command queue. So the command queue generates the command buffers. So as you can see, I'm not actually going to be going over this like a tutorial. I'm just going to do it. So let command queue equal MTL, or as an MTL command queue. And then I also create system default device. Need to instantiate the device. Now I can create self.command queue equals self.device.make command queue. Gorgeous. So now I have a command queue, so this command buffer can be created with the command queue dot make command buffer, and I can create a render command encoder. So render command encoder equal command buffer dot make render command encoder with a descriptor. Now we need the descriptor. I'm going to do this beautiful little line of code. So guard let render pass descriptor equal view.current render pass descriptor, else return. The view has the next render pass descriptor, so I'll return. Just going to check my yeah, see, I don't know how to change it. It says please check the video resolution. The resolution is terrible, which is not optimal. It could be my OBS. Let me go into the OBS. Whoa, recursion. Let me go to I don't know what the best. I don't know what the hell I'm doing. What is studio mode? Settings. I think I can't mess with the stream, like the output, unless I turn it off. So the encoder is software. Okay, that makes sense. There just needs to be an HD button, you know? That would be so much better. Anyway, I guess since you can see, should be fine. It's OBS for sure. It's OBS. All right. Let's see here. I mean, maybe if I go to my video capture or my display capture. Properties? Whoa. Yeah, that doesn't tell me anything. It doesn't like say make it better. These are transitions, controls. Yeah, this is ridiculous. It makes it way too freaking hard to whatever. You said you can see it? Alright. That's all that matters. You sent me an email. Look at it on my phone. I'm not going to go on my email on my computer. Oh. Oh. So you want me to do C++ entirely? Game init, get instance. That would be amazing. I know C++, but I'm not a pro at it. Yeah, I can't do this, man. Sorry. But I will create... I thought you meant with like the shaders. So with shaders, you can create the bridging header and then have a C++ shader struct class. So both your Swift and your shaders can use the same code. They can use those same structs. I'm not entirely sure how to do this with C++. However, this looks pretty useful. I didn't even know you could code this in C++ like that. Well, thanks for sharing. Sorry, man. I got to do this in Swift. That's some complex stuff. I got to text a buddy back. He wants to play Fortnite. I'll get as far as I can tonight on this. I told him 30 minutes. I'll play Fortnite in 30 minutes, or he'll be okay. All right, so let's create this render pass descriptor. We'll go render pass descriptor here, and then I can go render. Render command encoder dot set. Dot end encoding, and then we have our command buffer dot present. I can go view dot current drawable, and then command buffer dot end encoding, or commit end encoding. So what I've done here is I've generated a render or a command buffer using the command queue that we instantiated. The command buffer can be loaded up with as many render command encoders as it can. We can also do compute encoders and blit encoders, but for the time being, we're only doing render command encoders. Then we're ending the encoding. So right here is where we're going to be doing all of our drawing. And once we're done drawing and putting everything on the screen, we can end the encoding, and then we can present whatever we want to the view. Looks like we probably need to do that right there and add a question mark after the command buffer. Alongside up here, this needs to be a var. Sorry for being terrible at Swift. I don't know if you know this, but I do not do Swift as a profession. I'm not a professional Swift developer. I never have been. Only I regularly do Golang or C# or JavaScript. I never actually do Swift at work. It's all hobby stuff. All right, so we created the command queue. What I want to do now is I just want to clear the screen. So up here, I can say self.clearColor, because MTK views have a clear color, equals MTL clear color, and we'll just do red as, we'll just do, I don't know, random numbers. I'm not even thinking right now. I don't want it to be all this red though. It's too much red, in my opinion. I wish there was a way we could just like watch a movie and do this together, because I love watching movies while I code. Look at that. Look at our snake screen. Oops. I resized it, and I know for a fact that my main storyboard, if I go back into here and go to game view, or excuse me, if I click on this little window and I go here, it'll say restorable. I need to uncheck that. But we're clearing the screen, so I'm going to push that up. Pushing stuff up. Make sure everybody has it. It's right on master. Not even doing branches, because who cares? Cool. Let's see. But I can see it's not that. Maybe up the font size in Xcode. Oh yeah. Okay. Making snake with net metal. I'm gonna make this bigger for you. Look at that. It's a lot. See what the biggest line is. There we go. Yep. So now we have a clear color. The next thing we need to do is we need to set the self dot pixel format, color pixel format. We're just about done with the basic setup. We BGRA unorm sRGB because I don't want to do gamma correction. So sRGB does that automatic gamma correction for us. Pretty amazing. So if you can do BGR8 unorm, but if you tack this little thing over here, you don't have to calculate anything extra. All right, color pixel format's done. I want to draw a triangle on the screen now. So let's go up here and go, let's create our render pipeline state. So the render pipeline state is what's going to contain our shaders and actually how we draw our code. So MTL render pipeline state. This is probably the most boring YouTube channel stream ever because all I'm doing is coding. It's like hard. If I was playing Fortnite and wrecking like Ninja, I bet this would be so much more entertaining. But this is fun for me. All right, so we got your render pipeline state. Let's create it. So for our render pipeline state, we're going to need a couple of things. I'm just going to create a function down here. Func, that's going to be a private func. Private func generate render pipeline state. I will need the device, but don't need it because I'm in this file. The render pipeline state, we're going to need a render pipeline descriptor. So let render pipeline descriptor equal MTL render pipeline descriptor. The descriptor is all the properties that define what the render pipeline state's made of. The one that we can do immediately is render pipeline descriptor.color attachments at 0 dot color pixel format, or I guess it's pixel format equals dot BGRA unorm sRGB. We can also go render pipeline descriptor dot, well, we can't do that yet because we need a couple things. All right, so here's where our vertex shader and our fragment shaders come in. We need both those things. So what I'm going to do is outside of display, I'm going to create a new group. I'm going to call it graphics. Ooh, being slow. Graphics. I'm going to create a new file, and I'm going to call it, it's going to be a metal file, and I'm going to call it, let's just call it basic shaders. How about just shaders? Shaders.metal. So this will be our shaders.metal file. See if anybody's chit-chatting. Snake with metal. All right, so I'm going to create two shaders because we're going to need these shaders to be used on the CPU. So I'm going to create two shaders. It's going to be vertex. It's going to return a... Okay, we're going to need a struct. I want to make sure we dev as fast as possible. This will be rasterizer data. Struct rasterizer data. This is the stuff I wanted to put inside of a bridging header so that it can use it. So let's do that actually. All right, I'm ready for this. I'm excited. I've never actually done this. So I'm going to create a C++ file. I don't want a header, but I'm going to call it our shader types. Now I'm going to press next and I'm going to put it in here. And I know for a fact it's going to say create a bridging header. And I'm lost. I'm already lost. I have no idea what I'm doing. I'm so scared right now. What did that say? Exposed to Swift. Okay, so how about shader types? So CPP? Is that a thing? Cool. Holy moly. All right, so shader types. Let's create a struct here. That's not how you do a struct. Trying to remember how to do a struct. I think you can go. I know the golang struct. That's the problem. If I just go struct like that, and then don't I call it like? I'm just gonna try to do it normal. So I'm gonna call it rasterizer data, and this will be float for position. I also need to include this. I doubt this is gonna work. See, I'm telling you, I'm lost. I'm already lost. It's like I don't even know what that is. Metal STD standard library. I don't even know what that is. Can I include SIMD? Let me see if you're saying anything. Nope, not saying anything. Okay, yep, not doing this. I'm already confused. I'm confused as shit. Let's just make some. Let's just make snake. Shader types.cpp. Delete. Move to trash. Build. Please build. Well, it didn't build. So what I need to do is I need to just do a copy of all that. And we're just going to discard some stuff here, actually. Does that build? Does that make you happy? It looks like it's working. All right, cool. Go here, new group. Group is going to be called graphics. Oh, I already have the graphics. Let's go to projects. I have a lot of projects in here. Snake 3.0. Going to Snake 3.0. Get rid of this group. That's the problem. All right. So we're going to call you graphics. Graphics is going to be all, oh my good nasty. Graphics. New group. Side graphics, we're going to put our shader back. Okay, yeah, I don't know how to do that bridging header stuff. I never actually dove into that too much. I could probably look into it and do a tutorial on it, though, if you really wanted me to. This is going to be called shaders.metal. Inside shaders.metal, we're going to create a couple structs. The first one being a vertex, so struct, so that whatever goes out of the vertex shader is going to be the rasterizer data. In vertex, we're going to need, for snake at least, we need a couple of things. We need float 3, and that's going to be a position, and I'm just going to put that at attribute 1, which is actually 0. And then the next thing I need is a float 2, which is a texture coordinate, because I will want to add some texture stuff on this. Attribute 1. Who's in here? Anybody else? We got 3 concurrent viewers. Mom, are you out there, Mom? That's my boy. Coding away. I love box wine. All right. In rasterizer data, we're going to have the float 4 position, because in order to use the position attribute, it needs to be a float 4. We're also going to have, well, let's just do that. Okay, so we have our rasterizer data, and it's going to have position. Let's go ahead and make our vertex shader. So to make a vertex shader, it's really straightforward. Just say vertex. That's the kind of shader I want to make. What are you returning? Well, it's going to be some rasterizer data. What is it called? Well, this one's going to be Vertex Shader. It's a hard name. Add the little parentheses, and boom, we have a vertex shader. I'm going to be taking in a const. Actually, let's not do const. Let's just do vertex v in. That's going to be at stage in. So since I'm going to be doing per vertex, I'm not going to be doing any of that per pixels sort of stuff. I'm going to need stage in, because I'm going to define the vertex on the CPU that I'm passing into the vertex, because we're going to need to describe this data on the CPU, and we can use stage in with that. Cool. Cool. Everyone on board? Wow. You guys get this so well. You're so smart. Rasterizer data RD. Simple little rasterizer data that I'm going to return. RD. Should I create the model constants and scene constants? I should. I'm not actually like doing a tutorial, so we'll do model constants. Model constants are what describe the translation, or I guess the transformation of our snake. So all the different all the objects in our game engine are going to need to be translated, rotated, and scaled at some point. And so our model constants will contain what's known as the float 4x4 model matrix. We need our model matrix. And then we're also going to need some sort of, This will be scene constants. I like calling them scene constants because I know that we have an entire scene full of things, and I mean, I could call it view constants, or I don't know. Just a scene contains a million objects, whereas I guess a scene contains a bunch of models. Yeah, whatever. You know what I'm trying to say. So I'm going to create scene constants. I'm actually probably getting a little tipsy. This box wine is delicious. Oh man, that'll be fun if I start getting drunk and talking to myself for hours, because this is live streaming. And yeah, anyway, view matrix. View matrix is relative to the camera, and I do, so kind of spoiler alert for this, I want to make this like 3D snake. We're going to start with 2D because it's not hard to start with 2D, and then we're going to turn those quads into cubes, and then we can do 3-dimensional snake, which would be pretty sweet, and maybe do like a camera perspective from the snake's eyes. Oh, that would be so cool. That wouldn't be that bad. Easy peasy. So we have a view matrix, and then we have a projection matrix. Now there's two different types of matrices. There's the projection matrix, or perspective matrix, and orthographic matrix. When it comes to the projection matrix, perspective, orthographic. Orthographic's is better designed for 2D, but I'm probably going to go with perspective matrix just because I will want to make this some sort of a 3-dimensional game at some point. So view matrix, projection matrix. Sounds good to me. So I'm going to take those in down here in this. So this will be model constants. This will need to be a reference. Constants. Can't spell because spelling is really hard. I didn't do too good in spelling in school. Buffer 0. And then the next one's going to be our scene constants. Oh man. And the model constants. If you have any questions, feel free to ask them. If you like want any, like if I'm going over anything and you think, oh, I don't know what the hell that is, I don't mind answering any questions, at least to my knowledge. The best of my knowledge. All right, this must be constant. Can't modify it, I guess. So this is kind of interesting. If I put constant here, I can't modify this. So that buffer, that broker that stores the memory that the CPU accesses and the GPU accesses. This is actually super interesting. I'm gonna draw it up. So I have patina. I freaking hate patina, but you know, sometimes it's really good for quick drawings. So basically we have this broker that, let's say this is the CPU and this is the GPU, and I'm gonna type that real quick. This is CPU, this is the GPU, and inside of here, this is our broker. Inside of our broker, if we want to access this data with the CPU or with the GPU, so right here is like some memory that we want to access, and the broker, like when we set the memory inside of the GPU, the CPU and the GPU can still access that memory. If we want to update it in the GPU, what we can do is, instead of doing constant right here, we can do device. And if you do device right there, that means you can modify it, and then the CPU will grab that modified value. But if you do constant here, it won't actually modify it. You can't modify it. It's constant, right? It's just like normal C++. Oh, the way I'm sitting. You hear that? Oh, I should have put my... Whew. I'm sitting so proper right now. See, all right, and then so now we have model constants and scene constants. Let's create our position. So float 4. I'm gonna call this world position. We're gonna need this later on. That's gonna be our model constants dot. Oh my lord, model constants dot model matrix times float 4 vn dot position 1.0. Right, so that's our world position. Now we can go rd dot position equals, well, we can just do world position xyz, or still we'll do it the right way. we'll do scene constants dot projection matrix times scene constants dot view matrix times world position. Amazing, amazing. And then another thing I'm going to need to return from the rasterizer is float 3. We're going to need, or float 2 texture coordinates. We need those texture coordinates, and we're going to need float 3 world position. I'm going to push this up. You wait. Equals world position dot xyz, and then we also need those texture coordinates, which I'm going to do first. You don't need to, but which is vn dot texture coordinate. All right, checking for questions. No questions. Nobody gives a shit. I got 2 viewers right now. Nobody wants to learn about metal. They just want to go and watch Ninja. Ninja's the shit. Can't blame it. Can't blame the people out there. I'm gonna make this up 1 and that 2. All right, we've created our vertex shader, which took 5 hours. Fragment. This is going to return a half 4. This will be called our fragment shader. This will take in our rasterizer data, RD, at stage in underscore in. And I'm not going to do anything else. I mean, I could take in a texture. Nah, we'll just do rasterizer data. A color? Nah, we'll just do rasterizer data. So we're going to return, I'll go float or color.rgba. I can just do color. Cool. So we have a vertex shader and our fragment shader. That was a really long, I'm out of breath. All right, so now what I can do is I can create a couple of things. So up on the top, I'm going to create a default library, which is an MTL library. Library will be instantiated right here. So self.default library equals device.make default library. And inside of the library, we need a couple of things. We need to go, we'll go let vertex function equal default library dot make function. And that function is going to literally be the name of our shaders, which is Vertex Shader and Fragment Shader. So we have Vertex Shader, go back to game view, put that right there. And we have Fragment function, which is going to be our Fragment Shader. I'll just call this Fragment function. And here we go. Render pipeline descriptor dot set vertex function. Oh my goodness. Set dot vertex function. It's been a while. Vertex function equals vertex function. Render pipeline descriptor dot fragment function equals fragment function. Pretty cool. Let's check questions. Nope. Half the memory of float 4. Dude, I have no idea. I've actually meant to look this up for the longest time. Let's just go to the metal shading specification. So when I have questions, I usually head on over here, and I've been meaning to Google this for the longest time. So, yeah, so it looks like a float 4 is 16 bits, and a half 4 is half of that. And I don't know exactly why, because you know RGB, so red, green, and blue, each one of those is 4 bytes, right? No, 4 bits. So there's 4 bits in a color, so 255 is 0, 1, 2, 8. Sorry, God, I'm like computer scienced out. All right, so we have 8 bits in a byte, which means that we have 8. I have no idea. Yeah, sure, half. It's half, literally half, and I don't know why. I'm just too drunk to know what the hell this stuff is. I should stop drinking. All right. So, yeah, I'm not actually sure why they use half 4. It works. So I guess it works. if you got a better explanation, if you like are out there Googling and you happen upon some better explanation on why that is, it's like compressed data, right? So how do they still manage to get the same exact color quality? I guess maybe if they're using like lab color space, which is a lot bigger. So if you ever go into like the color sync utility, is it the color sync utility, I think? This is super interesting. If you go to the lab profiles, where are we at? Yeah, so we go to profiles, and this is on your computer. If you have a Mac right now, you can go view this stuff. But this shows you the different color spaces and like how much they take up. So if we just go to the basic Adobe RGB, this is how much memory it kind of consumes. But if we go to the lab color space and go into its lab profile, look how much more color it uses and how big it is. So this is 4 kilobytes of color that it takes up, and this is only, this is like a fourth of how much, 560 bytes, which is relatively interesting. Like, that's interesting, right? So maybe if we were using some sort of a different color space with our view, we're using .bgra, unorm, sRGB, right? If we're using maybe lab, like is there some sort of a lab color space inside of the metal shading specification? A bunch of them are. Maybe one of them does represent lab, but I bet that's kind of the idea. Is like we don't need all of that space to create the basic red, green, and blue color. So 8 bytes might be enough. I'm not sure. I'm really not sure. I'm gonna close that because my GPU is gonna fry. See, it's at 6. All right, so where was I? Render pipeline descriptor dot. I need a vertex descriptor. So let's create a vertex descriptor. Vertex, it's going to be let vertex descriptor equal mtl vertex descriptor. Vertex descriptor. Now, we need to describe what our vertex is made of. It has a position and a texture coordinate. So we're going to go vertex descriptor dot attributes. God, I can't think. Dot attributes at buffer index equals 0. I'm just gonna go up here and copy this whole line, and I'm gonna put that down here and right there. And this needs to be dot offset. We'll move that one to the bottom. And this one needs to be, what is it? Type? Can't remember. Format. And this will be dot float 3. We're going to be at buffer index 0, and we're not going to be offset at all. And this is going to describe the position attribute. If we go back to our shader, position attribute at 0 is that. Now, if you have questions regarding the layout of the vertices, please feel free to go in here and ask a question. Just like, let's see. General question. Say with a full proper big game, would you compile all the shaders at the start or load? Yeah, you definitely load them all to begin with. There's a way. So it depends on what you're doing. So you said a big game, right? So what's kind of cool is I've never actually done it like this, and maybe I should, but I know there's a way you can go default library .make function. Oh, what is it? No, maybe it's not this way. There's a way that you can compile shaders on the fly at runtime. You don't have to pre-compile them. And I think what you're asking is, can we load them, like lazy load them, maybe? Okay, so if you're asking if we can lazy load them, the answer is probably not. If you have a big game, you want to load those resources as early as possible. I mean, so like think of Fallout. When you're walking into a room and it takes 5 minutes for it to load. Those are more assets that it needs to compile and load up to walk into that room. And the shaders are an asset, right? They're you don't think of them. They're just code. They're script, but they're still an asset. So when you walk into the room, you don't want to load up your shader. Just have those loaded It's not that much space. Now, say you make Unity. So you want to have some sort of a shader editor in your Unity-based app. You want to be able to update lighting calculations on the fly with your scripting. What you can do is you can, I don't know how to do it. I know there's a way, so I'm sorry I can't actually show you off the top of my head because I read this online. You can compile, so you can write just like right here, var string, or how about vertex equals, and then you can do the whole entire, just like an OpenGL, where you do core or use OpenGL 3 point. I'm not familiar with OpenGL 100%, but you can also go vertex rasterizer data right here, and do your function name vertex function, and you can do this and compile it at runtime, which is really useful because if you have some sort of a Unity-based shader program that you want to update on the fly, you can do that. But it's not good if you have a big game, right? Because if you have a huge game, you'll want these assets loaded. If you played Rocket League, that shit is fast. You get into a game, all those it takes maybe a millisecond for that thing to load, and you're into a game. Fortnite is kind of a pain in the butt because that loading screen takes like 10 minutes, but that's because they have like 5 million assets. So maybe they could probably, I guess it just depends. I hope that answered the question. Like I said, I'm not actually, I would load them all at the very beginning. It's not that much space. And that's my question, or that's my answer. Yeah, so we have Vertex Descriptor .attributes 1. So we have float 3. This is going to be a float 2. Buffer index still 0. Offset is going to be, here we go. I'm going to go and dive into, so I'm going to create a file in here, and I'm going to call it metal types because I need to go steal. I'm going to go steal some code from my other project, wherever the hell that went. Apparently it left me. It left me forever. Yeah, let me know if that answered your question or if you have something more specific. I wish I worked more in industry. I watch a lot of like Cherno and Thin Matrix, and like I read so much. I found a site that it's this one right here. But basically, I probably shouldn't show it. Oh, that was it. So yeah, it basically has tons of reading material on it. If you reach out to me, I could probably send you the link. But it has a lot of reading material. Personally, I don't like going on there and taking the books because, I like supporting authors of books because I want them to keep writing really good books. And so, yeah. Anyway, I read a lot of books. I spend the majority of my time reading about this stuff. Sorry, I'm trying to cover my ass. I'm not getting anybody in trouble, especially a cool site like that taken down. Let's see. So I need my types. So I'm going to go into utils. Where are you? Shaders. Shader types. Okay, so shader types has my shader types in here. The one thing I need, as I'm just going to take all this code and I'm going to throw it into my metal types file right here. Basically, this sizable, if you've seen my tutorial, you know that I had this sizable class that allows me to do the stride and size of an object based on its memory layout. So I'm just going to make that. And yeah, I'll have Boolean that's sizable, uint32 that's sizable. And now out in my game view, I can go the offset is going to be, it's float 3, so float 3 dot size. You use size when it's one individual object or like item. So if you have like an int or a float or a something, just int. What's the name of them? Yeah, basic things. Then you use size. If this was, let's say, my vertex, the whole entire vertex, I would want to do stride because it contains float 3s and float 2s and float 18s and all sorts of different data types kind of packed together. And so you'll want to use the stride of that whole thing. But if you're using just if you're using just like float 3 or float 2 or float one, whatever. You'll want to use size on each individual one. So we're going to do size here, and then we need a vertex to be able to size it. So over here inside my metal types, I'm going to create a struct. I'm going to call it vertex. Vertex will consist of var position, which is a float 3, and var texture coordinate, which is a float 2. And vertex needs to extend sizable, so that over here inside of the game view, I can say vertex descriptor dot layouts at 0 dot stride equals the whole vertex dot stride. See, vertex, if I go back to my metal types, you'll see vertex has multiple items in it. So it has a float 3 and a float 2. So I need to stride over every single one of these. Whereas if I'm just doing a float 2, one individual, then I use the size of that. And it has to do with padding, like different padding between the items inside of the struct. Let's see if pretend none of what happened. Oh yeah, yeah, none of it happened. This is on YouTube for the rest of forever. I don't know how it works. But yeah, super useful. Not gonna go there, right? All right. Oh God, I have way too many viewers right now. Can you guys like not hit YouTube so heavily? It's ridiculous. I might need to get a wine refill in just a moment. I don't know how to pause this, so you're just gonna have to wait. Let's see. So we have our vertex. We're just about there. We're just about drawing. Vertex descriptor. Now we need to set our render pipeline states. Render descriptor, vertex descriptor equal dot vertex descriptor equals vertex descriptor. Thanks for joining, by the way. That's awesome. Like you're hanging out with me. It's kind of awesome. I don't know who the hell you are. You're just a guy out in the ether. Somewhere out there in the world. You could just be a bot. I have no idea. But I like hanging out with robots sometimes. So now I've created my render pipeline descriptor. What I can do is I can go try render pipeline state equals, do, this needs to be a do try, do that equals try device dot make render pipeline state with that descriptor. And so that should be good. I need to catch it. Luckily I have that error, so I'm gonna go print error right here, and we can go render pipeline state. This doesn't need to be very nice. You just need to know it's the render pipeline state. Then right here I'm just gonna put that error. Error kind of comes loaded in this do. It's pretty sweet. So now we have our render pipeline state. Generate render pipeline state. Up here in the initializer under command Q, actually under everything. I should put this in multiple files, I know, but I'm just trying to flow with it. Generate render pipeline state. So now we have our render pipeline state down here inside of our draw function. We can now say render command encoder dot set render pipeline state to render pipeline state. Oh my goodness, it's so much boilerplate. It's not even that bad. Like if you look at Vulkan, Vulkan takes like 1,000 lines to get hello triangle. 1,000. How many is this? Like 80. We're getting pretty close to our hello triangle already. All right. So let's create a couple other classes because that's going to be a pain in the ass to kind of break out later. So I'm going to go under here, create a new group. I'm going to call this the game. I'm going to put that under graphics. And inside of game, I'm going to create a new file, and I'm going to call it node. This node, so I know, let's call it mesh. Let's do the mesh for now, so that we can get a triangle on the screen. Then we'll come back to the node and adding game objects in a second. So here we go. Import metal kit class mesh. And we're just going to do a basic mesh right now. So public init. Actually, we'll just do init. First thing we're going to do is we're going to need to build our vertices. So we're going to need private vertices. That's going to be an array of vertex equals empty array. This needs to be private let or var vertices. So what I'm doing is I'm creating the mesh data, the actual lines and connections that create the mesh of our object. Let me make sure I'm not talking to myself. Okay, yeah. So the mesh class is basically going to be all of the primitives put together. So we'll have a bunch of triangles in space attached, right? And all I really need for this basic snake game is a quad. So I'm just going to create a quad. I'm going to actually call this a quad mesh. And what the quad mesh is it's just made up of two different triangles side by side, and that's it. And so we're going to have 4 different vertices on them, and then we're going to have private var indices, which represent that. Now, inside the chat, if you want to know more about this, go ahead and ask some questions. What's up, dude? What's up, Plat? Dude, just so you know, I started learning German. So, wie geht's? De heute. Equally nice to make the same thing in C++ with, I have no idea who this guy is, and it's awesome. But yeah, wie geht's? And then I know a really cool word is ausgezeichnet. I don't know if I said that right. If I did, let me know. But if you have questions, feel free to go throughout this little side chat thing and let me know. So I'm going to create indices. Indices are going to be uint 32s. We could just do ints here. It'll convert it when I send it on over to the GPU. I'm going to create a function. So this is going to be a private func. And I'm going to title it build vertices. Actually, it's just going to be build mesh. Inside of build mesh, we're going to create that vertex. And now I like to create a private func helper function, add vertex. And the vertex takes in a position, float freaking 3, and texture coordinate, which is a float 2, and I'm going to instantiate that to float 2, 0, 0. And then I can just say self.vertices.append a vertex. Position is going to be the position, and this is going to be texture coordinate. Build mesh now can say I want to add 4 different vertices. So if I go over here to my patina and I go don't save and I just kind of create a new patina. I mean, I may as well explain a couple of things to you in case you are new. We want to create a quad. This is a quad because it's made up of 4 vertices. There's one vertex. Let me grab this circle. There's one vertex here. There's one vertex here. Here, and here. Now, if you can count, which I think you can count, that's 4 vertices. 2 triangles, 4 different vertices. And so we need indices to make up, you know, like, yeah. So we need a quad. I just wanted to kind of make sure you understood where I was coming from. I'm just going to come in here real quick. Sehr gut. You're supposed to say, like, sehr gut, danke. And then I say... what do I say? I have no idea what I say. I say, yeah, I can't remember. I've been trying to learn German, and you're right, it is easy. It's super easy. It's super similar to English. There's some things that are weird. You know, like if I were to tell you that I would like the receipt, please, it's not, can you bring me the receipt? It's like, can or can you that please bring me or something. Like it's the way it's phrased is super weird, and so trying to get that. Anyway, I'm trying to do some metal here, Platin. All right. I've also been drinking, so I'm a little tipsy. Sorry. You know, Moscato really gets you going. I got 3 concurrent viewers, dude. I'm basically famous. Build mesh. Let's build this this quad. So let's call build mesh here. I'm going to add a couple of vertices. Add vertex. Position is going to be the float 3 of. Let's do the top right vertice first. So we're going to go 1.0 here. 1 to the right. 1 to the butt. Up. The butt. And then I'm just going to copy this. 3 more times. So we're going to have a quad, 4 vertices. The second one is going to be to the left. So I'm going to go -1, +1 on the y-axis. And then it's going to be to the bottom left. So I'm going to go -1 on the x-axis. And -1 on the y-axis. And this will be +1, -1. All right, and I'll make sure. So this is going to be our top right, top left. This is going to be bottom left and bottom right. See if you said anything. Famous. Famous. That's me. All right. Now we need to add some indices. I'm not going to create a special function for adding indices. I'm just basically going to go indices.append. So we want the top right, top left, bottom left. Well, depends on how we want to draw it. If we want to draw it like we did with this patina, we need this one first, then this one, then this one. But I don't like drawing it actually like that. I like drawing it not like that. I like drawing it like this. Oh boy. Where we have top left, top right, top left, bottom left. And then we're going to do the next one. So we're going to do top left, or excuse me, top right, which is 0. Top left is 1 indice. Bottom left is going to be 2. Then we need top right, bottom left. So top right is going to be 0. If you have questions about this, you let me know in the chat, and I'll explain it. I don't want to stop too much. Top right, bottom left, which is going to be the second indice, and then bottom right. Cool, right? Oh, you need to do append. Here, you got to do it like this. Contents of. Sometimes I just don't understand why. Like one of the things I dislike about, seems to be an array. I don't understand about like what they updated. So if you look at the new version, actually, if you understand why you can't just go float 3.0 now, and you can, but they deprecated it, replacing it with this repeating. So if you actually want to just do 0 for all 3, you have to go repeating. So if I fix this, it'll say repeating 0. So basically that looks like float 3.0.0.0. Why? It just seems so. I don't want to have to type an entire new word repeating for that. I don't get it. I just don't get it. Oh, maybe I'm just complaining. So I'm going to build the mesh, and then I'm going to build the buffers. So we're going to go private func build buffers. This buffer will be, let me just check, make sure nobody's shit talking me. All right, that's right, better not be. Just kidding. All right, so buffers, we're gonna need a vertex buffer and an index buffer. So I will say up here, private var vertex buffer, MTL buffer. Man, I don't have anything resembling Snake yet, but I will. At some point in my life, I will. So we're going to go vertex buffer equals, I need a device, don't I? This is where my cool little engine class comes in, because I don't want to call this from everywhere. So I'm going to create a new Swift file. It's going to be engine. And I'm going to go steal code. Let me go steal some code real quick from engine. Oop. Engine's really cool, because it will be the singleton for, it's actually not even a singleton, it's just a static class, I guess. It's not a singleton. If I had like some sort of an instance.device. Anyway, engine will be a singleton. I'm going to call it a singleton, where I can grab device from anywhere in my entire application. So in order to instantiate engine, it's really easy. I just need to go to my display, my game view, and just go down here, or I guess right after device, go engine.ignite with that device. And now I can use that device anywhere. Isn't that amazing? You want that? You want that device unwrapped? I'll give it to you. Cool. And now I can even right here, I can go try engine.device.make render pipeline state. Or the command queue. Actually, the command queue is already created in the engine, so I don't need to do that. Don't need that. What is going on here? Okay, so we have engine ignite. This is going to break because I'm going to take away the command queue because my engine contains a command queue. It also contains a default library. Doesn't contain a render pipeline state yet. So right here, we're going to go engine device.make default library. I'm just going to copy this because stuff's going to be broken. I don't need to do that. I just need to go like this. Engine.default library. Engine.default library. Pretty cool, right? I doubt you're a long way out. Platin 21. Probably don't want to tell people your real name, but I'm going to show you real quick. Snake. This is what we're making. We're making this. This is the snake we're making, and once we, God, the boilerplate takes so long. You know what I should have done? I should have done boilerplate before this stream. That's what I should have done. God, hindsight's 20. This is gonna take me all night. Who wants to stream all night? Okay, so we're gonna fix this. Fix this right here. Build buffers. Engine.device.make buffer. Bytes are going to be our vertices. Length is going to be vertex dot stride with the count of vertices dot count. Let's bring it down so that we can see it. Options are going to be, we'll just keep them. I mean, I could do share. Well, let's do it. I don't even know if I can do private. Dot storage mode. I'll try it. If it breaks, fine. But I'm never going to update these, and I think that's what this is used for. Then we need the index buffer. I'm probably being corrected by all 900 of you watching me right now. Equals this. Let's see, length. This would be uint32.stride. Indices.count, and we'll do private. And it's going to break. I'm rocking 5.5 gigs. Questions? I can't wait to download your boilerplate for my own. Yeah. It'll be boilerplate. Just to get hello triangle. What do I have in here? This is what I want. Actually, I think I already have some boilerplate somewhere out there. Oh, my mother's calling me with WhatsApp. I'm answering my phone. Hello, Mother.
Oh my God!
What's
it
up?
works. Hi, baby.
Hey, Mother. I'm streaming on YouTube right now.
I love you.
I love you too, Mama.
This is so cool.
Yeah.
He helped me.
Oh, hey, what's up, man?
Hey, I just put it on WhatsApp.
Oh, yeah.
That's Bradley. He is my number one here at the bakery.
Oh, hey, Bradley, what's going on?
Yeah, he runs it. Yeah, they're in there. 3 cases. Freezer. Hi, honey.
Hey, Mama. I do have to get going, but thanks, Bradley, for setting my mom up with WhatsApp.
This is like so cool.
Yeah, it is cool.
This is cool.
When I'm in California, you'll be able to WhatsApp with me and Corey. But
That is like,
all right.
This is so cool.
All right, I love you, Mama.
Honey, I'm in the 21st century now.
Get it, Mom.
I love you.
I love you too. See ya.
Okay.
Oh, oops. I hung up on my mother. Oh, she's so sweet. Okay. Indices.count. So we have our build buffers. We need to call build buffers. My mom. I'm in the 21st century. Yeah, right on. Now we need a func called draw primitives. This is just how I like to set up my meshes because this kind of consolidates all the mesh logic into one. And let's see. It's more than Hello Triangle. It's an entire metal template project with a quad class. Oh, sure. Sure, man. So we're going to go render command encoder. So with draw primitives, I need to take in a render command encoder. MTL render command encoder. And then we can say render command encoder dot draw index primitives. So you can do draw primitives, but since we have indices, we're going to do draw primitives instead. So we're going to do indexed primitives. Let's make this look a little nicer. Metal's not too bad. It's a pretty easy language to get. Like once you have the hang of it, you can kind of just do it. You don't need to think about it. But it does take some time to understand, I guess. Unfortunately, uint32 index buffer is going to be index buffer. It's hard to talk and do this at the same thing. Index buffer offset is going to be 0, and then I'm also going to do instance count here, which is going to be 1 to begin with. And I'll talk about that in a little bit, because like if you watched this one's particle effects, like you'll see like those little particle effects, like where I hit the apple. That's actually like a particle emitter, and I'm instancing those. So I'm setting multiple instances, so it's just a lot faster. If you haven't noticed, there's a battery draining right now, and which means I can only go so long on this laptop. My battery seems to be effed up, but I will, if I can't finish this right now, I'm not going to continue it. I might just jump on tomorrow, let my computer charge up, jump on tomorrow, play Fortnite with my buddy, but it's slowly ticking down, and having a mic and a camera plugged into this thing is burning out that battery. Let's see here. Okay, so draw primitives, we'll do that, and from my game view now, where I do draw, let's create a mesh here. So var mesh, it's going to be my quad mesh. Now, if you're smart, you'd break out this quad mesh into like a generic mesh, because it is a generic mesh. We just only need a quad mesh. Oh, just mesh. We only need a quad right now. We'll probably need a cube later, so we can break it out like that. All right, yeah, nice. Now we can just go down here to our render command encoder, and I think we go mesh.draw primitives with our render command encoder, and unwrap it, or make sure it's not nil. Let's just press play and see what happens. I think we're going to be satisfied here. Yeah, it's not very satisfied, and I know why. I know exactly why. It's because of storage mode private. Okay, let's just do storage mode managed. I think it's managed by default, or is it shared? I think it's managed by default. But oh well. So we're going to have our vertex buffer and our index buffer. Nice. Okay, that's what I wanted to see. So you see right here where it says missing buffer binding at index 0 for vertex buffer. Okay. Because I'm not actually going render command encoder dot set vertex bytes or buffer. And the vertex buffer. Offset's going to be 0. Index is going to be 0. So we need to first set our vertex buffer, then we need to draw. So it'll draw for every single one of our primitives sets that we put together. The next thing that breaks is we need our scene constants and our model constants. Okay, that's actually not that bad. We're making really good progress. All we need to do is go into game view and create two things. We need to create our scene constants and model constants, and we're going to extrapolate these out in just a second, but we're going to create scene constants equals scene constants. And we're going to go var model constants equals model constants. All right, and then we just need to bind those. So I'm going to go render command encoder dot set vertex bytes. It's going to be the reference to our scene constants at scene constants dot stride and 0. Actually, this will be 1. Now, we haven't actually made our scene constants and model constants in metal, so I'm going to go down here. I'm going to go struct model constants, and above that, boom. So I have scene constants and model constants. Scene constants consists of our var view matrix equals matrix float 4x4 and our var projection matrix. The model constants only has the model matrix. These need to be matrix identities, by the way. Float 4x4s. I think that's it. It's not. It will definitely yell at me. Let me see what's up. Stride. Oh, and I also need to make these sizable. So scene constants will need to be sizable as well. Cool. So if you notice, we have our vertex scene constants and model constants, and on our GPU inside of shaders.metal we have our vertex model constants and scene constants. So these need to match exactly the structs that are on the CPU side. Okay, any questions? Does anybody have any questions? Yeah, I'm not sure. Float 3 is deprecated in current beta, so I guess we will not care about this miner. CTOR. It's a CTOR. All right, so now that everything is good, we need to go back to our game view and just kind of copy this line and also set our model constants at index 2. Yeah, and this will be really good. So if I go play, oops, this needs to be model constants anyway. It's gonna succeed, but all right. Yep, see, we're at 25%. We're gonna make it, guys. We're gonna make it to at least draw on a grid. Look at this. All right, where's our quad? Does anybody know where our quad is? So let's go debug on the GPU. So I'm gonna press play and see what the hell's getting sent over to that GPU. So if I go into the editor and press this little camera at the bottom, looks like when we're calling draw primitives, our vertex attributes states that, it's running a little slow, need some wine. It's not that much left. Oh my goodness. 1.34 gigs. I think my computer might explode. I don't want it to explode, but I think it's still going to explode. All right, Xcode, you win. I'll try to figure out this solution myself. You son of a beast. Odds are I'll probably be on tomorrow, if or maybe even later on tonight. It just kind of all depends. But I'll still stream. We have 5 viewers. Let's go. What's up, peeps? Holy crap. I'm like top of the charts right now. Let's open up Xcode again. This quad! Once we have a quad, we'll be able to, oh man. Once we have a quad, it's all downhill from there. All right, it gets a lot easier once we have a freaking quad on the screen. Let's see here. Let's make sure. 8 gigs now. So when you hit that GPU, that thing really does work on your system. So let's just kind of go through the flow. So we create our mesh, we create our buffers, we add some vertices, then we call draw primitives. We have our index count, which is the count in our index buffer. Okay, okay, that all makes sense. Let's go back out to our game view. Let's see this draw. So we say set render pipeline state. Render pipeline state contains Vertex Shader. Okay, yeah, that looks good. This is at 1, this is at 2. If I go into my shaders.metal, let's just do this. So get rid of those multiplications and press play. And maybe something will happen. Something magical. I really want to debug. The reason I know it's not showing up is because we have it as red. All right, I'm gonna try this debugger one more time. 7.484. Just dropped 3 gigs. Yeah, I don't think. Oh, it's at 1 gig. Oh my god, it takes so much of my memory. All right. I think, boys and girls, that's out of the question. Also, it's burning my battery, and we can figure this out. It's not out of the realm of possibility to figure out. Gee whiz, constructor. Yep. All right, so I'm just doing that. Draw is definitely getting called because I'm clearing the screen, and we see that things are coming through. Okay, I might know. Let's pop back out here. Mesh.draw primitives. Just gonna put a breakpoint on there. Yep, it's definitely hitting here. And we have our scene constants. So down here I'm gonna go PO model constants. See what it poops out. Got our model matrix. Just the identity matrix, nice. I'm assuming scene constants is fine. I've done this a million times. This shouldn't have taken me so long. Sorry, people. Yeah, we have at 1 and 2. That's fine. Huh. Game view. 0, 1. Layouts. Vertex function. Fragment function. Mesh equals quad mesh. It's going to be something stupid. I really wish I could just debug with my GPU. I'm going to look at a couple more things. All right. It could be that I'm drawing it wrong. Anybody have any ideas? No? Nobody? Okay. Let's see. Texture. Can I click the bytes? Oh man, should I do it? Oh, buffer. Oh, cool. That was gonna break. All right, so we have 4 vertices coming in. We have our top right, top left, bottom right. Texture coordinates are 0. That's fine. Okay. Scene constants are coming in. View matrix, projection matrix. Okay, that's fine. Ooh, I don't know. Oh. What is this? I don't actually see a fragment shader. I see a vertex shader. I don't see a fragment shader. Do you guys see a fragment shader? Exactly. Because you don't. You don't have to have a fragment shader. It's not mandatory. Because, like, say you're doing depth testing and all you need is that depth buffer or that depth texture. You don't need a fragment shader in order to get that depth texture. So, for some reason, it's not actually using my fragment shader. Fragment shader. Is it spelled wrong? I've never seen this before. You know what I'm going to do? I'm going to just go up to source control and I'm going to go to, I'm going to go to product and I'm going to clean my build folder. Then I'm going to press play. Sometimes this works and it's really frustrating. Rasterizer data returns out to my fragment shader. What in the name of RD, return RD, world position? This looks great. Actually, we could seriously just set our position to that. We're returning RD, rasterizer data comes to stage in. We have our position, that's just fine. Anybody else going crazy? Am I going nuts? let's see. Who said anything? Who's trying to be helpful here? Did you actually add the metal view to the... Yeah, it's hitting. It definitely is hitting that breakpoint. Yeah, the metal views, the game view's on there, and it's hitting the draw for sure. And we have our fragment function being added to our render pipeline descriptor. So we have render pipeline state. Pipeline state contains the vertex function and the fragment function. I'm just going to go look at some other code. I don't know what I'm doing wrong here. Where am I going? Really, I could, if you want, I could just go through this code. I was hoping I didn't have to do that. If I go to game view, so all the key input stuff. I have a game handler in this one. See, we set that render pipeline state. We go to scene constants.stride. Yeah, thumbs up. I'm not giving up though. I bet it's the proj matrix. You think so? Well, the projection matrix is a identity matrix right now, so it's basically 1. What I could do for the time being, just to make sure that we're neither of us are going crazy, let's just not pass in any matrices. Let's just because this is the most basic of shaders right here. We don't actually need that other information. All we really need is a position to be passed from the vertex shader into the fragment shader. Okay? And so over here inside of our game view, we don't actually need to set these vertex bytes either. So if I do that, and you're right, well, yeah, see? And then if I go into draw primitives, render command encoder. Oh, there's the fragment shader. Okay. Fragment shader showing up. Good news. I don't want to click that vertex attributes button. So now we have our positions coming through in our texture coordinates. That the attributes button is really nice because it says what goes out and into post vertex. I feel like I'm taking crazy pills. Oh, I clicked it. Oh my gosh. Did I do it? I did. There it is, 1.81. Why does it? I think it's OBS mixed with metal that breaks everything. Anybody else have any ideas? Index buffer in right order. You know? Yeah, I gotta quit this again. I think you're right. Tell me, out of curiosity, when I have 1 gig of memory rocking, does it slow down? Let's see. So you said, let's go to my mesh. It could be. Oh! Woohoo! Right there. See that? This whole time. It's always something small. Almost always. My computer sounds like it's about to take off into the sky. Like a jet. A rocket. Alright. I pressed play. Nothing happened. Okay, well, we're now sending indices there correctly. I'm going to actually do this because we'll be able to 0.5, 0.5. So I'm going to normalize it to length of 1 because if this is 0.5 and these are 0.5, then it's, 1 total. What the hell am I doing? 0.5, and then we need to go here and go like that. All right. Okay, so that was one small issue. We have vertices, You know what? Let's get rid of this. Let's just do this. It could be this. That's another issue that it could be doing. We have index count. Index type is that. Our buffer is the index buffer that we built. The offset 0 and the instance count, we're drawing one of them. We're doing top right, top left, bottom left. Then we're doing top right, bottom left, which is at index 2, and then bottom right at 3. Okay. I'm going to press play, just see what happens. Anybody else see anything? It could be something to do with the stride as a stride. Thanks, man. Peter, you're kicking ass. I appreciate it. Yeah, I figured. Vertices in my place. You're so helpful. All right. Build mesh, build buffers. One thing that could be wrong is, no, it's all right. It's all perfect. It's not me. It's Apple. Apple's breaking everything. If I'm being honest with you, I'm actually pretty lost right now. Usually, present the drawable, commit. Huh. I'm going to be super disappointed if it's something dumb again, which it is. Float_d.side. Yeah. See, like if I go back to my other code, let's go to snake. Let's go look at those vertex descriptors. So if I go to my render pipeline states, so I use size here and then stride there. We're going to get through this together. Vertex Shader, Fragment Shader. Let's go look at the render pipeline descriptor in my other one. Let's see here. These look good. Vertex Descriptor. Yep. Mesh.draw primitives. Alright, we're going to press play. I really wish I could just debug on the GPU looking at those vertex attributes. That would help so much. Maybe, I wonder if I stop streaming and then restart. Probably take a minute. Okay. Just clicking vertex attributes takes so long. I wonder why that is. Alright, position, texture coordinate. Those are the correct positions. Ooh, look at that. That doesn't look right, does it? That is totally wrong. All right, so I figured it out. If we go to our mesh and look at how I'm adding. Yep. So let's just. All right. So I'm gonna do this in a very. Just go like this. Dot append 0. Actually, you know what I could do? I could just go equals 0, 1, 2, 0, 2, 3. I don't know if that's okay. So what I'm saying here. Oh, it's probably this right here. Let's just go make sure what I'm doing over there. Let's go to our meshes. Let's go look at this. You went 32. It's this right here. Like and subscribe. Uint. I use the lowercase u. Oh, I use the simd uint. Okay, we're gonna go in. All right. Anybody else got any just count? Maybe? See, look at this should be 6 different rows. Right now, it's 2 rows. So, you know, if I go over here and look at if I go here, press play and go into that debugger like so, it's going to show me the indices. I didn't actually make this beautiful or anything, but if I go to the index buffer, well, I guess it does. 0, 1, 2, 0, 2, 3. 0, 0, 1, 0, 2, 0. Well, that's wrong. Okay. I'm not lying to you. I've done this before. I'm not going crazy. Did I make this ints? Try to stick with me, people. Let's go up here and see, it's always the smallest little dainty things. Oh my god! Oh my! Oh my goodness! Oh. Lou, I need you to look at that. Look at it. Look at how beautiful that rectangle is. Yeah, he doesn't want to look at it. It's beautiful and you know it, mister. Yeah, he's pissed off. He's just disappointed in me and how long it took me to get this thing on the screen. That's all it is. All right. All right. There we go. Throw you one of those. Okay. So let's push this up. We have it. Okay, I'm gonna push it up. Drawing a quad. Committing to master. Pushing to origin. All right. Also, if you do want the other snake game, I have that up in my GitHub as well. If you go over to my GitHub and just go over to snake, should be on here somewhere. Go to my repos and go to snake. Is it public? I have it on here. I'm not going crazy. Let me go here. Yeah, let me see if it's public or private. Settings. Yeah, so if you go to snake, this is the actual snake that I showed you like a couple minutes ago. So you can go check it out. My cat just threw up on the wall. This is so fun. All right, so my battery's gonna die. Cat threw up on the wall. They're just like, I don't know if you can see this. Let's see. They're over there just looking at it. And one of them's gonna start eating it. So I'm gonna actually end the stream, but I will let you know when I'm on next, and I'll get back on. I need to clean this up and obviously charge my battery. So I don't know. Yeah, I'm glad you had some fun. That was super basic setup, but I promise you we will create snake and it won't be that bad. So I'm gonna end the stream now, but you all take care. See ya.